Sketch the curve y is equal to x times the square root of 2 plus x. Our domain is 2 plus x is greater than or equal to 0. So x has to be greater than or equal to negative 2. So the domain is negative 2 to infinity. For the intercepts, f of 0 is equal to 0 times the square root of 2 plus 0, which is just 0. So our y-intercept is 0 and 0. For our x-intercept, 2 plus x is equal to 0. So x is equal to negative 2, or x is equal to 0 as well, which is just the same as our first point. So our x-intercept is going to be negative 2 and 0. For our symmetry, f of negative x is not equal to the original function or the opposite of the original function, so we have no symmetry. For the asymptotes, as the rules say, the limit as x approaches positive and negative infinity is just itself, and the limit as x approaches our point of interest, negative 2, from the right and the left, does not equal positive or negative infinity, so we don't have any horizontal asymptotes either. Now to find out what intervals the function is above or below the x-axis, we solve for the original function, which is going to be x is equal to 0 and x is equal to negative 2. Since our domain is negative 2 to infinity, it's going to be below the x-axis from negative 2 to 0, and from negative 0 to infinity it will be above the x-axis. Now for the next step, intervals of increase and decrease and finding the local max and minimum values. We find our derivative, and which is over here, 4 plus 3x divided by 2 times the square root of 2 plus x. For our critical points, where the derivative of f of x is equal to 0, or it does not exist. It doesn't exist at negative 2, since if we put a negative 2 in here, that would make the denominator 0, which will make the function undefined. And 4 plus 3x is equal to 0 would make x equal to negative 4/3. So we put those on the interval, and we're going to have the f prime is decreasing from negative 2 to negative 4/3, and increasing from negative 4/3 to infinity. And since we're going from decreasing to increasing at negative 4/3, we can plug that into our original function to find a local minimum, which is at approximately negative 1.1. For our next step, we find the concavity and points of inflection. And our second derivative here, which is 1/2 2 plus x to the negative 3/2 times 4 plus 3/2 times x. Again, we're going to set it equal to 0 and see where it does not exist. Again, it does not exist at negative 2, and f double prime of x is equal to 0 at negative 2 and negative 8/3, but negative 8/3 is not in our domain, so that will not count. So from negative 2 to infinity, it's going to be a concave up. So it is concave up throughout the entire domain, and there is no point of inflection. Okay, we have our rough sketch here. from -2 to 0, the function is is below the x-axis. From 0 to infinity, it is above. From -2 to -4/3, it is decreasing. From -4/3 to infinity, it is increasing. From the entire domain, it's concave up. And here's our sketch of the graph right here. I put the important points down first, which was our intercepts, -2. Let me get a little closer here. -2 and 0 and 0, and -4/3 and approximately -1.1, which was also our local minimum. So started at -2, went to the local minimum, and then back up as our directions kind of guided us there. And that's it.